There are three choices you can write code. One is manual. You can manually write code line by line. But I don't think so anyone is doing it in 2026. But if you're still doing it, you're a legend. Next is vibe coding. Or you can call it as like simply asking AI to do X in a chat. It's like a one of prompts. Many people are doing it and face issues. And then they say either vibe coding is dead, or it's bad, or it is not possible to do it in large code bases. Or the third way is context engineering, the way how I am approaching frontend in 2026. And actually, I started it on it last year and I really found some good results. Okay, by the way, we have moved to the second point, how AI is actually changing frontend development in 2026, or how I personally use AI in my day to day work. Okay, let's back to the topic, context engineering. One obvious question now is, what is context engineering, right? So for me, context engineering is about giving AI the full picture, how you code, your complete plans, your requirements, design files, workflows, rules, everything, the whole context of what you're trying to build in a proper manner. So it can actually build the things the way you build, not hallucinate. In short, context engineering is how you stop AI from guessing and make it work the way you work or your team works. And if you check the software development cycle again, a lot of that data AI needs or the context it needs is already there, just scattered across different tools or steps. Let's go back. So context files are already present. You just have to look closely. Okay, let me help you. First is requirement docs. These are the actual data, the context the AI needs. Where it present, it's in Conference. Next is the backend tasks, the API docs. Next is Jira task. It has the details of the exact task which needs to be done, the description, the comments. Next is Figma files, right? These are all the context, the design, layout, screenshots, every context which AI needs. So just to sum this up again, where are the context files? And the resources where it is available is requirement docs, that is in Atlassian. You can get it into your AI code editor via Atlassian MCPs. There are MCPs available and you can actually link those Confluence docs. Next is Jira tasks and task details, from where you can source it again via the same MCP. It is the same Atlassian MCP. You can actually refer to a Jira ticket and it can get all the context. Next is backend API docs. You have those online Swagger links which has all your API details, the types, the objects. And if you're using Supabase, there are Supabase MCPs and that can actually talk to your databases. Even if you don't have any fancy MCPs, you can actually copy YAML files of your API docs, copy paste it in your code, and then refer it. Next is Figma designs. You have Figma MCP available. So it has screenshot support. I have seen many developers just screenshot the UI and try to give context. But if you connect Figma MCP, you will get all those details, all those variables, and different things. So it will make your AI life easier. And next is official documentation links. For example, text that you are using, and you can give all of them also as context. Apart from all of these contexts, there is one more layer. And honestly, this, according to me, is the most important one. Remember the second key point I asked you to focus in the last section? This is exactly that. The last and most critical layer of context, something very few companies are actually investing in, is your project specific cursor files or cloud scales. This layer connects everything. It's like a magic. So, because this is the layer that tells the AI how your code base is structured, you have all of this context, all this data, right? But there needs a common layer, some context files which can tell AI how your code base is structured, what tech stack and technologies you use, your personal preferences, how your team prefers to write code, the exact structure, what coding patterns to follow, because it depends and varies based on team to team, what abstraction to respect, and most importantly, what not to touch. Think of this layer as the steering wheel of the car. All the other context gives engine power, but this decides where the AI goes. Most teams are using all other context right. But what they're trying to do is they're trying to control all of this context using one of prompts. That's fragile and it doesn't scale. The next obvious question is, what do I actually mean by context files? What it actually looks like? What kind of context files should you or your team be creating specifically for frontend? This is where the requirement of core skills comes in. And this is exactly that most good engineers and experts are pointing towards: design systems, architecture, and good coding practices. At this point, you have to stop thinking about front end as React code and start thinking more about it from first principles. Let's break this down and look at few context file examples. Here are few project specific context file example. Number one is design system file. What it can contain? It can include design tokens, your variables, your component rules, like how to update your code when your Figma changes via MCP. This can have those rules. Your context files can include exact routing and component architecture. folder structure, how your paths looks, where your code goes, your component boundaries, everything can go into this context file. Next is layout and composition, how you exactly want your components to look like, when they should break, your hierarchy, your responsiveness, how you want to handle responsiveness via props, via styles, dark and light mode, all these roles and patterns goes into this. Next is Figma to code orchestration layer. This is a very important layer because this is the place when you ask AI to convert your Figma designs to the actual code. This can actually control whether at this stage only you want to make the backend API calls, you want to integrate that code, or whether you want to first complete the layouting via Figma MCP and then make the backend API doc. So there is a lot can be played here. Next is you have API handling. This covers all the information about your full data, like all your current operations, where your types are present, how you are writing them, whether you're using interfaces, types, hooks, whether you're getting hooks for the data passing, your error handling. Next, you can have state management rules, very clear rules on how to use local versus global state. Libraries like TANS type of rules, how you're writing them, the caching terminology, because all of this is a repeatable code, right? You can actually define context files for it, the patterns which are allowed or not allowed. Next, you can have form handling, context files. Example, when you're creating any form, whether you are using React hook form, it could be like different library, how you're handling the validations, your loading and skeleton states, your success, error handling. Many things normally goes missed in most general apps I see. But this is important in the large scale production application. Next is testing, how you are testing it, what test cases you are writing, and you can create context files for accessibility, like area rules, how you want to handle keyboard navigation. Is there any scroll behavior handling required? The defaults, the security, your like cross-site scripting testing you have to do. You can run this context file. There are open redirect issues or patterns you want to save. So all of this can go on into this context files. And yes, you can create many more as needed. So just to summarize again, these are the different design system files, routing and component architecture, layout composition, Figma to code orchestration layer, API handling, state management, form handling, testing, accessibility, security, and there can be many more you can create. The real skill of context engineering is adding the right level of detail, optimizing these files for the context window, making sure AI picks the right context without being overloaded. This takes iteration, time, and a lot of core expertise and experience. I've just started going deeper into this approach, honestly, and I've already seen very strong results for myself and my team. So now, when someone says AI will replace front-end developers, you can confidently say AI doesn't replace front-end developers. It amplifies the ones who understand systems, context, and architecture. And now, with that, we have covered context files. Next, one more important thing, which is part of this, how I'm approaching front end in 2026 is using plan mode. This is also very important because the custom context files guides the AI to write code in a predictable way that matches your architecture and preference, right? This is what we saw. Next is feature planning. Like when you're on a particular task, when you're in a plan mode, it ensures the AI always has the right context, even when a particular feature implementation takes days or weeks. So you can pick exactly where you left off, phase by phase. So this is that second part. One is giving all the context, having those files ready. This feature planning plan mode is specifically when you are on a particular task, how to approach it. Okay, so plan mode is basically about giving the AI as much relevant context as possible before implementing a feature. So that context can come from above, like MCP servers, which we have discussed, task, Jira details, backend, API docs. And then before you start planning or creating any feature, always first go into a plan mode, try to understand it, and then go to the implementation mode. So plan mode is important for a particular single task. And a lot of back and forth discussion between AI and you. Discuss the entire feature with AI, requirements, edge cases, trade-offs, almost like you're talking to a senior developer who wants a complete picture before touching the code. And at the end of every prompt, I always add something like, please ask any questions before finalizing the plan or implementation or anything. Because what I observed is it is eager. The AI is eager to start doing something to create that plan. Or if you're in agentic mode, to start writing the code fast. So it stops it. And do not make code changes unless I'm confirmed. So this is the exact prompt I write when I'm in the plan mode. This single line changes everything. During this phase, you will uncover edge cases you didn't think about, scenarios your PM or manager missed, limitations in the current code base, because that is where plan mode is very helpful. This helps close open loops in parallel. While designers or PMs or backend teams resolve those open questions, you and your team can actually start building what's clear. So it is very helpful in pre-planning. Next is one more thing I've recently started asking the AI is, especially for complex tasks, is Also, please break the plan into logical, chronological phases. Okay, I know it sounds very rhyming, but the idea is to divide the plan into parts, into phases, because to have more control on big tasks, which I think will take days or maybe sometimes weeks. Benefit of this approach is each phase can be tested properly. I can code review it, and you avoid massive risky PRs in large code bases. It's like giving the AI a shared memory: what's done, what's left, and how we have reached the current state. The real goal here is end-to-end clarity of what we are building and how we are building it. So it's not vibe coding. If you look carefully, it's not just generate code and hope it works. The vibe coding approach might be fine for smaller throwaway projects, but for large production grade applications, it's a recipe for disaster. But if you go via this approach, you will be amazed by how complex task AI can handle via context files and plan mode when you break features into phases and work step by step. So my final thought is, even after all this, creating these context files, doing this plan mode, I don't think AI will do everything and genius will disappear. It's much more than coding. Honestly, I hope that happens because it means you are no longer writing boilerplate code that you anyways never enjoyed. That's why framework came into existence. Instead, you get to focus on what actually matters, bringing complex and useful product ideas to life in a scalable, maintainable, flexible, reliable, and secure way. Remember that mantra.